Second part of 4.1 deals mainly, or the big part, is coterminal angles. Okay, we'll talk about coterminal angles, and then we will talk about like the length of a circular arc. So basically kind of going backwards from what we did yesterday, where we found the radians given the radius and the arc length. Now we're going to be given the radians and the radius, and we'll be able to find the arc length of the circle. So coterminal angles are really pretty straightforward. Basically two angles with the same initial and terminal side, but possibly different rotations, are called coterminal angles. So what does that mean? Basically, you have the same angle regardless of what it looks like. So basically what that means is if you have any sort of circle, okay, or if we think about on a circle, or if we think about if here's my initial side, and say that the terminal side ends somewhere over here. Okay? Say that it's 100 and, like, if we just look at it, we measure it, we go from there, and we take it for what it's worth. Okay? Meaning that it's not over 360 degrees, because we're just going to take it as, say, 135. Okay? So if we look at it, we measure it, it's 135 degrees. But what really happens is that whenever we rotate everything around, is that really we go like a full rotation. Okay? So from here to here, okay, or if I do it this way, if I go to there, I went 360 degrees around, right? And then I still end at the same place, but I may have went, maybe I went 2 laps around, maybe I went 1 lap around, and then I finished somewhere else. Okay? All a coterminal angle is really like, kind of like what we talked about yesterday. We could even talk about it being a negative and going kind of backwards. That it's going to look the same because it just keeps spinning in a circle. That you may go around, I'm going to use a NASCAR reference here, but the cars go around the track 500 times. But where do they ultimately start and end every single place? Or a track athlete or whatever. What do? Okay? How many times whenever you run a race, do you just run the course once? Yeah. Okay. Well, that doesn't work for me then. Okay? But whenever you run track, you're on the 2 mile, okay, or the mile, whatever, anything over a lap, what do?
4 or 8 laps.
Yeah. So he's going to start, like, depending on where Sam starts, okay, he's going to pass by his new starting spot. He may run less than I know it's not 360 degrees, but depending on where he starts, he really may not run a full lap. Or he may run a full lap plus something. Okay? Stuff like that it's not necessarily, it's where you start and where you finish, but you don't know kind of what happened in between. Does that make sense? You know that, like, when Sam starts the 2 mile or the 1 mile, and if he starts on the start-finish line, nobody knows. Everybody just knows whenever the clock started when he went and the clock ended when he crossed the finish line. Coterminal angles are really the same thing. Okay? It's all about, everything's dependent on 360, or really those multiples of 360, because say if you went around 2.5 laps, or you made 2.5 rotations with your circle, then you're still going to have more than 360. So what you're going to have to do is you're going to have to add or subtract 360 degrees from whatever angle that you are given. Okay. Now, depending on, we talked about yesterday with it being a negative. So if we backtrack to a negative value, okay, to find the same thing in a positive direction, we just have to add 360 degrees. So, like if we have 420, That's above 360. So all I'm going to do is just take 420 degrees, and I'm going to subtract 360 degrees. I'm going to basically subtract one full rotation is all I'm going to do. Okay, subtract one full rotation, end up with 60 degrees. So a 420 degree rotation is going to end at the same spot as a 60 degree rotation. Whereas with B, with it being a negative 120, instead of subtracting 360, all I'm going to do is I'm going to take 360 and I'm going to subtract the 120. Okay? Or you could write it as negative 120 plus 360. Either way, it means the same thing. Okay? You're still going to get 240 degrees. Okay? Or it's at the same ending point, if you think about it, as 240 degrees if you go in a positive direction. Same way with the 400, same way with the negative 135. Okay? It's completely up to you. If this number is bigger than 360, you're going to take that number and you're going to subtract 360 from it. You may have to do more than that. Okay? So 360, 720, if it's more than 720, you're going to take 720 or take 360 twice from it. Okay? Same way, if it's a negative 135, I can either go 360, not plus, minus 135, and we're still going to get the same thing. Okay? Or I could go negative 135 and add 360 degrees. Now, same way, but in terms of radians, so we dealt with degrees. Degrees obviously are easier because there's no sort of fraction here. Whereas with the radians, everything's in terms of 2 pi. So remember that with the main ones that I'm going to deal with, I'm going to have I've got to pay attention to whatever my denominator is. So if I have 17 pi over 6, okay, realistically, I can get rid of the pi's, and I need to check to see, like, 17 over 6, what I would tell you to do, if it's a number bigger than 1, if it's an improper fraction like it is on A and like it is on C, is I would turn it into a mixed number and kind of go from there. So if it's a mixed number, what is 17 over 6 as a mixed number? How many times can 6 go into 17? 2 times. How many are left over? So really that's 2 and 5/6 pi. So what am I going to do, or what do you think I'm going to do with that 2 pi? What did we do before? What did we do up here? We subtracted it. We're going to do the same thing again, and we're going to subtract 2 pi. So the 2's are gone. I'm just left with 5/6 pi as far as my angle. Now, I don't know what that is. We'll get to that later. But again, it's just in terms of radians. Radians are just another way of doing it. Same way here. Now, so let's go ahead and do C, since C is the same way. So first things first, I need to, how can I change this into an a mixed number? How many times can 5 go into 13? 2 times again, right? So 2 and 3/5 pi, and then subtract 2 pi. So what do I have left? 3/5 pi. Now, whenever it's negative, again, I'm going to do the same thing. What I would suggest to you is I would take your 2 pi, and since it's negative, and just straight subtract whatever fraction you have. Okay. Now, the one thing that you're going to have to do in the cases of, especially the subtraction, or the ones that you don't have necessarily maybe a 2 as your lead number as far as a mixed number, that I'm going to have to turn, like I'm going to take 2 pi minus pi over 12, okay, which is really just 1/12 pi. I need to make sure that I turn the 2 into having a common denominator of 12. So 24 over 12 pi. So what's 24 minus, I mean, it's really pretty simple. What's 24 minus 1? 23 over 12 pi. You can leave it like that. Since it's not bigger than 1, okay, basically I'm going all the way around until I get to the very, like almost to the very end of where I started. Do the same thing with negative pi over 15. So I'm going to take, okay, or you can write it as negative 1 over 15 pi. Now, how do I need to rewrite 2 pi in terms of the 15th power? Or excuse me, the 15th is my denominator. 30 pi over 15, or 30 over 15 pi. Either way. So then the last part deals with the length of a circular arc. So really it's just it's the opposite of what we had before. Okay? So yesterday, whenever we found the radians, okay, what we did, we're going to let r be the radius of the circle and theta be the non-negative radian measure of the central angle of a circle. Okay? So the length of the arc intercepted by the central angle is s equal to r times theta. Remember yesterday, whenever we did this, we tried to find theta, and we had r over s. Excuse me. Yeah. Okay, so what I've got to do, if I have the central, I've got to first know what the radians are as far as if I'm given a central angle of 120. So first thing I need to do on any of these is make sure that it's in terms of pi. So whenever I do this, remember that if I have 120 degrees, okay, if I have 120 degrees, I need to turn this into, I need to take 120 degrees and I need to multiply it by pi over 180. So then I can convert it to radians first. So in doing that, what is 120 and 180 going to reduce to? What can I divide both of those by? 60. So I'm dealing with a 2 up here, a 3 there. So my theta is really 2 pi over 3. Then all I'm going to do is take what's in red here and multiply it by whatever my radius is. So all I have to do I want to write this in terms of inches, so I'm going to take 2 pi over 3 and I'm going to multiply it by 10. That's the same thing as 20 pi over 3. That's the exact answer. If it asks for everything in terms of inches, okay, and it wants you to round to 2 decimal places, then just type in 20 pi, divide by 3. You're going to get somewhere in the neighborhood of 20.94 inches. Either one's okay. Okay, pay attention to see what it asks. If it asks for everything in rounded, then you can round it. Other than that, leave it in exact form and just leave it as 20 pi over 3. Same way. They give us the central angle. They have 45 degrees, so I need to turn it into radians first. So if I have 45 over 1 times pi over 180. The 180 and the 45 can reduce. It's going to reduce. That's going to be a 1. That's a 4. So theta is just pi over 4. Radius of 6 inches. So all I have to do is take that times 6, get 6 pi over 4, which is really going to reduce to 3 pi over 2. Again, round to 2 decimal places, so that is about 4.71. A lot of what we're doing right now is really just plugging it into formulas that you're given. Same way whenever we talk about linear and angular speed. So the biggest thing is the difference between linear and angular speed is the example that we use is you go to the zoo and you go to a carousel, okay? And what's happening? The carousel's doing what? Going in a circle, right? What are the actual animals doing though? Yeah, they're moving linearly, right? So you're really moving technically in 2 directions, right? You're moving up and down because you're on the animal, and you're moving in a circle at the same time. Okay, so if you ever notice, if you sit on the animal and you look up on the rod, really that animal is on a rotation, basically like a wheel, as you go up and down. Okay, while you're also moving, while something else is spinning circularly on the carousel. Okay, so if a point in motion on a circle has a radius of r through an angle of pi radians, okay, in t time, okay, then it's linear speed, where the arc length is given by s equal to r times theta, and its angular speed that's omega, okay, it's a lowercase omega which is which is theta over t. Okay, so the biggest thing is you have 2 different values. You're going to have to find to find the linear speed, you're going to have to use the angular speed. So, like it says, a wind machine used to generate electricity has blades that are 10 feet in length. The propeller is rotating at 4 revolutions per second. Find the linear speed in feet per second of the tips of the blade. Okay, so the propeller's one thing, and then the tips of the blade are going to be a little bit different. So the first thing that I want to do is change my change omega, okay, and put it in terms of radians. So if I have 4 revolutions, what is it, 4 revolutions per second? So if, it's really just going to look like a W, okay, is equal to 4 revolutions per 1 second. If I turn this into, I need to turn this into radians, I'm going to have 4 revolutions over 1 second. And I need to multiply this by 2 pi, okay, because what is a revolution? It's 1 full circle, right? So 2 pi is the same thing as 1 revolution. Well, the revolutions are going to cancel. So what is my omega in terms of, like, we're going to call it W because that's what it looks like. But what's omega equal to? Just what's 4 times 2? 8 pi, right? So from there we had our, to find the linear speed, I need to take V equal to R times omega. Well, what's my radius of my wind machine? Okay, my giant fan. What's the radius? 10. Okay. What is omega, or what's the angular speed per second? Okay, it's 8 pi per second. So then all I'm going to do is just multiply 10 times 8. So my angular speed is going to be at, or excuse me, my linear speed is going to be at 80 pi feet per second. You're basically just using one equation. You've got to find it first to plug it into the second one. Okay. So you're going to take the first one, you're going to take the angular speed to find then the linear speed. If you're given the linear speed, then you're going to use the linear speed to plug it into the angular speed. Okay? You're just basically using 2 formulas to, you've got to find one to plug it into the other is really what you've got to do.